Welcome to UBG Bytes.
Great to be here.
Today, we're diving headfirst into the evolving landscape of AI security. It's something I know is top of mind for you information security professionals listening.
Definitely.
We've got a fascinating set of sources here that really unpack the unique threats AI presents. And we're going to take a good hard look at a protocol that's becoming really quite important in how AI systems interact.
It's a critical piece of the puzzle.
Our goal, well, is to move beyond the buzzwords,
Yep.
equip you with practical insights to actually secure your AI deployments.
Cut through the noise a bit.
Exactly. It's a bit of a wild west out there with AI right now, isn't it?
It really is. Changing fast.
Trying to secure it sometimes feels like, I don't know, trying to nail jelly to a wall.
Yeah.
But let's see if we can bring some clarity today.
Absolutely. And look, it's not just about future risks. The sources we have paint a clear picture that AI security is a very real and growing concern right now.
Right now.
We're seeing both the tactics and the targets become more sophisticated and quickly.
Yeah, that KPMG finding really hit that home, didn't it?
It did.
The fact that, was it 89% of surveyed companies admit they lack the necessary tools to even secure their machine learning systems?
89%. It's huge.
That's a pretty significant blind spot. Makes you wonder, is it lack of awareness, skills gap, or just the tools haven't caught up yet?
Well, it's probably a mix of things. The lack of specific AI security tools is definitely a factor, but I suspect a big part of that 89% also reflects just how new these threats feel, and the challenge of adapting our sort of traditional security frameworks to AI and machine learning's unique ways of working.
That makes sense. It's one thing to secure a network or an app. Securing an intelligent system that learns, that evolves. That probably needs a different mindset.
A very different mindset.
And this isn't just theory anymore. KPMG also pointed out that a large majority, 75%, expect to move from just piloting AI to full-scale operational deployment this year.
Yeah, 2024, that shift from the lab to the real world, it just dramatically elevates the security stakes.
Right. Because if it's in the lab, a breach is bad. If it's running your core business.
Exactly. The potential impact escalates exponentially. And this urgency, it's underlined by things like the OWASP POP 10 for large language model applications.
Ah, yes, OWASP. Always good to keep an eye on their lists.
It's basically a catalog of the most critical vulnerabilities we need to be thinking about right now with these big AI models.
Like a cheat sheet for where things can go wrong.
Pretty much.
Prompt injection is one that jumps out immediately. The idea that someone can manipulate the AI just through clever input. How's that different from, say, standard input validation issues we already deal with?
Well, what makes prompt injection particularly tricky in the AI world is how opaque these models can be.
Right, the black box problem.
Exactly. Unlike traditional code, understanding why the model reacted that way and then patching it, it can be way more complex. Needs new approaches to testing, monitoring.
So it's not just sanitizing inputs anymore.
No, it's about understanding how the model interprets and acts on those inputs at a much, much deeper level.
That's a key distinction, and the list goes on, right? Insecure output handling, basically don't trust what the AI spits out.
Critical.
Training data poisoning, that sounds nasty. Like long-term sabotage.
Can be, undermining the very foundation of the model.
Then sensitive information disclosure, insecure plugin design. It's a broad attack surface.
It really is. And that IBM survey data, it just highlights this disconnect, doesn't it?
The one between knowing it's important and doing something.
Yeah. 82% of execs say secure AI is essential. Great. But then only 24% are actively securing their generative AI projects.
Wow, 82 versus 24, that's a significant gap.
A huge gap, one that you have to assume threat actors are looking at very closely.
You'd think so.
Yeah.
IBM also mentioned some of the fundamental challenges, right? Beyond specific model bugs, like the sheer amount of data involved.
Exactly. These massive data sets for training and running AI, they create unique challenges for data security, for governance. Then you've got managing access for all sorts of different roles, potential weaknesses in new apps built on AI, and the risks that come with open source models where the security isn't always, fully transparent.
Okay, so lots of challenges. How are security folks approaching this? IBM proposed a framework, you said. 3 core principles.
Yeah, IBM's framework is pretty straightforward conceptually. It focuses on securing 3 key pillars.
Okay.
First, secure the data the AI uses. Second, secure the AI model itself from attacks. And third, secure how the AI is actually used in its environment.
Data model usage.
Right. It's a holistic view. Protect the whole life cycle.
Got it. Okay, so we've set the stage. AI security is critical, lots of challenges, known vulnerabilities. Now let's zoom in on this specific tech, the Model Context Protocol, MCP. What is MCP exactly, and why should you, our listeners, have it on your radar?
So MCP, the Model Context Protocol, it's an emerging open standard, and it's designed to standardize how AI models, or what we're increasingly calling agentic applications because they can act on their own,
Agents, right.
how these agents can securely ask for and get information or even trigger actions from all sorts of different systems and data sources.
Cisco called it a USB-C port for AI applications. I like that analogy.
That's a good one.
Instead of building custom integrations every single time an AI needs to access something, MCP gives a consistent way for AI to connect with documents, databases, APIs, web search results.
All of the above, yeah. That's
Yeah.
precisely the power of it. Imagine an AI assistant that can just seamlessly pull data from your CRM,
Okay.
analyze it against your latest project docs, and then automatically update tasks in your project management tool.
The efficiency gains could be massive.
Potentially huge.
But, and there's always a but in security.
Always.
Cisco rightly points out, with that kind of power comes big responsibility and potential security headaches.
Definitely. When you have AI able to tap into so many systems, the risk of unauthorized access or misuse, it goes way up.
So granting AI that level of access, you need a really robust security framework around it. Make sure interactions are authenticated, authorized, audited.
Absolutely. Which is why understanding the MCP architecture is so important from a security standpoint.
Okay, so high level, how does it work? What are the security bits built in?
It's a client-server setup. The AI application, the agent, acts as the MCP host.
Okay, the host.
It uses an MCP client library to talk to one or more MCP servers.
And the servers are the gateways.
Exactly. They're the gateways to specific resources or capabilities, accessing files, querying databases, hitting APIs, whatever it is, all using the standard MCP protocol.
And that separation, host from server, creates security boundaries. They only talk MCP to each other.
That's the idea. It allows security policies to be enforced right at the protocol layer.
How so?
While an MCP server can be configured to strictly control what data it provides, no matter what the AI host asks for. And the AI host can be picky about which MCP servers it trusts and connects to.
Okay, some control on both ends. Cisco even mentioned zero trust potential with MCP.
Yeah, the design lends itself to that. Treating every connection, every request as untrusted until it's explicitly verified. It's a strong foundation.
Sounds good in theory, but I bet there are still pitfalls when you actually deploy it.
Oh, for sure. The architecture is a good start, but real-world implementations, they can introduce their own security headaches. Cisco and others highlighted a few key areas.
Right, let's get into those. What are the main risks InfoSec pros need to watch out for with MCP?
Okay, first big one, unmonitored access.
Meaning?
If you don't have proper logging and alerting set up, an AI agent could potentially access or maybe even change sensitive data through MCP, and you wouldn't even know.
Yikes. Like a compromised prompt leading to data exfiltration through a legit MCP connection.
Exactly that kind of scenario. That lack of visibility is always a huge red flag.
Definitely. Okay, what else?
Another challenge is the lack of built-in approval workflows in the core MCP spec itself.
So, no human in the loop by default.
Not inherently. For certain critical actions, think major database changes, financial transactions initiated by AI via MCP, you probably want a human to review and approve. Standard MCP doesn't force that.
Makes sense. You wouldn't want an AI accidentally or maliciously making big irreversible changes with no oversight. What about tracking things? You mentioned logging.
Yeah, related to the first point, limited audit trails and monitoring is another concern. MCP supports structured logging, which is good,
Thus?
but it doesn't automatically give you a complete detailed record of every single prompt, every interaction, every piece of data accessed. If something bad happens, poor logs make investigating really hard. And compliance reporting, too.
Nightmare for incident response.
Yeah.
And I guess managing permissions gets tricky fast.
Absolutely. Privilege management, making sure each bit only has the access it absolutely needs, least privilege, right?
Right.
That can get complex across a distributed OCP setup with multiple servers, different data sensitivities, poorly managed permissions. That could easily lead to overexposure or unauthorized access.
Okay. Potential dangers identified. Now, mitigation. How do we tackle these? What are the key security best practices for implementing MCP?
Well, fortunately, there's some clear guidance. Foundational stuff first. Strong authentication and authorization are non-negotiable.
Like what specifically?
You should be using standard protocols. Think OAuth 2.0, OpenID Connect. Verify identities of both the AI host and the users, kicking things off.
Okay.
And securely storing client credentials, maybe using proper secrets management tools like CyberArk Conjur or HashiCorp Vault. Don't hard code them.
Please don't. And the tokens, the digital keys. Secure handling there too, I assume.
Paramount. Use JWTs, set sensible expiration times, rotate them regularly, store them securely, HTTP-only cookies, secure mobile storage, that sort of thing. And, crucially, have a way to revoke tokens if something goes wrong.
Right. Token revocation is key.
And beyond just proving who you are, you need robust authorization what you're allowed to do.
RBAC and ACLs.
Exactly. Role-based access control lists. Enforce those policies using middleware. So even an authenticated AI can only touch the resources and actions it's explicitly permitted.
Makes sense. What about protecting the data as it moves?
Data security. Yep. In transit. Always use TLS. Good, strong cipher suites, valid certs, ideally with forward secrecy. No eavesdropping.
Standard practice, hopefully.
Should be.
Right.
And sanitize any data being passed between systems. Use libraries like Python's Bleach or JavaScript's DOM Purify. Prevent those injection attacks.
Good hygiene. Network security must play a big part, too. Preventing abuse.
Oh, absolutely. Rate limiting, burst control, use middleware or API gateways, things like Express Rate Limit and Jinx to stop DOS attacks hammering your MCP servers. Sensible timeouts for connections, reads, writes. Have defenses for DOS scenarios, circuit breakers, throttling.
And monitoring that network traffic.
Crucial. Integrate your MCP logs with your SIEM, Splunk, Graylog, ELK stack, whatever you use. Look for weird patterns, and of course, proper firewall rules, network segmentation, layers of defense.
Now, what about when you expose tools through MCP? Seems like the risk goes up if those tools can perform actions.
You nailed it. Exposing tools requires extra care. Input validation becomes absolutely critical.
How so?
Validate every parameter against a schema. Sanitize file paths, commands, URLs, like your life depends on it. Prevent command injection.
Yeah.
Check parameter sizes, no buffer overflows. Treat all input as hostile.
Zero trust for input.
Basically, yes. And access control to those tools needs to be ironclad. Strong auth, granular RBAC, audit everything the tool does, aggressive rate limiting, monitor for abuse constantly,
And error handling.
handle errors carefully, don't leak internal details and error messages back to the AI or user, but do log security-relevant errors thoroughly for your own investigations, clean up resources properly, validate return values, keep it stable and secure.
Okay, those are strong technical controls. Are there broader considerations?
Yeah.
More user-centric things?
Definitely. User consent and control is huge. Users need explicit control over what data AI agents access and what actions they perform for them.
Yeah.
Exactly. Transparent UI showing exactly what authorization is being granted. Linked to that is data privacy. Again, explicit user consent before exposing data, strong access controls, encryption to prevent unauthorized sharing.
Makes sense.
Tool safety is another big one. If a tool can execute arbitrary code, you need explicit user consent before invoking it. And clear docs explaining exactly what the tool does. No surprises.
Right.
And also LLM sampling controls. If the AI is sampling user data to generate stuff, users should explicitly approve that and have control over the prompts and the results.
That control theme is strong.
Yeah.
Our security best practices source also mentions specific attacks against MCP itself.
It did. The confused deputy problem. That's one to watch.
Explain that one.
It can happen if an MCP proxy server uses a static ID with a third-party auth server that doesn't handle dynamic client registration properly. An attacker might trick it into getting access tokens without proper user consent.
Ouch. Mitigation.
The key is, if your MCP proxy uses static IDs, it must get explicit user consent for each dynamically registered client it's acting for. No shortcuts.
Got it. Another one was token pass-through. Sounds bad.
It is. It's an anti-pattern. It's when an MCP server just accepts a token from a client without checking if that token was actually issued for the MCP server itself.
Why is that bad?
Oh, lots of reasons. It bypasses security controls, messes up accountability and auditing, weakens trust boundaries, might break things in the future. It's just, don't do it.
We rule.
MCP servers must not accept tokens that weren't explicitly issued for them, period.
Okay, these specific attacks really show you need to understand the protocol deeply and careful implementation. Monitoring these agentic setups seems vital too.
Absolutely critical. MCP supports structured logging, but dedicated tools like, say, Cisco AI Defense can offer much richer real-time monitoring and threat detection tailored for AI interaction.
More visibility.
Yes. And don't forget the human element. Human in the loop, confirmation controls for sensitive actions. That explicit user yes can be a crucial safety net. Prevent unintended consequences, even if an agent gets compromised.
Right. And finally,
Integrate all this with your existing governance, your data protection policies. Treat AI agents like a new user type in your security thinking. And obviously, keep your MCP software patched and up to date.
okay, so MCP, incredibly powerful, potentially transformative,
Mm,
but security has to be front and center, baked in, not bolted on.
precisely.
Is it actually being used much out there by InfoSec pros yet? Or is it still mostly developers?
That's interesting. Maybe not quite mainstream in enterprise security deployments yet, but there's definitely buzz, a lot of enthusiasm in the AI developer community.
Like where?
Well, over on Reddit, our Claude AI, for instance, you see users calling MCP insanely useful,
For what? What are they doing with it?
enabling Claude, the AI model, to correct all sorts of things, accessing private data like local databases or their Obsidian Notes vaults.
Wow, personal notes.
Yeah. Also pulling public data, like billboard charts,
Mm.
and interacting with work platforms Jira, Confluence, Asana for task automation, project management stuff.
And they can link these servers together for complex workflows.
Exactly. That's a big draw chaining connections for sophisticated automation, like update Jira based on notes in Obsidian.
Okay, that's cool. But it also sounds like it could get really complex to secure if you're chaining multiple systems and agents together.
It absolutely amplifies the need for robust security across that whole interconnected chain. No weak links allowed.
So wrapping up this deep dive on AI security and MCP, key takeaways for our listeners. What should they remember?
I think the biggest thing is, as AI gets woven deeper into systems, security just cannot be an afterthought, especially with protocols like MCP enabling broad
See
connectivity.
where you're in security.
A layered approach is essential, absolutely. And as CISA and others keep saying, securing the data, what feeds the AI, what it accesses is paramount. It affects the accuracy, the integrity, the trustworthiness of everything that AI does.
Yeah, joint guidance from CISA, NSA, FBI, international partners. It really emphasizes proactive risk management, strong data protection, continuous monitoring.
Non-negotiable in the age of AI. Security needs to be baked into the entire AI lifecycle, just like IBM said.
Data, model, usage.
Exactly. Build and run these systems responsibly with a security-first mindset.
Well, this has been a really illuminating deep dive. Super helpful stuff. Is there any other content you think we should touch on related to this?
No, I think we've hit the main points from our sources for today, covered a lot of ground.
Agreed. All right, then. This has been a Byte by UBG.